Hello folks and welcome back. Today we're going to be covering section 6.2, which covers multiplying and dividing radicals. Now let's see how much you remember by just going through and doing some of these problems. For starters, what's 3 root 5 times 2 root 6? How do we do this problem? Well, remember we do the outsides together and then we do the insides of the square root, or this becomes 3 times 2 times the square root of 5 times the square root of 6. Or this would become 6 root 30. From there, we'd have to simplify 30, see if we can pull anything out by reducing. 30 is divisible by 2, getting us to 15, which is divisible by 3, which brings us to 5, and 5 brings us to 1. So we fully simplified. What about 10 root 320? For this, we have to figure out what we can pull out from 320. So we're going to make our little chart here again, and we're going to see what we can divide. If we divide by 2, that'll get us to 160. If we divide by 2, that'll get us to 80. 2 will get us to 40. 2 will get us to 20. Let's keep going. 2 will get us to 10. 2 will get us to 5. And 5 will get us to 1. So what can we pull out? We can pull out 1 2, 2 2s, and 3 2s. Or this will be 10 times 2 times 2 times 2, or times 2 cubed, root, what do we have remaining? Just 5. Or this will be 80 root 5. Okay, what about for this last one? We have 8 square root of 8, or 8 over the square root of 8. Remember, we don't like square roots in our denominator. This goes back to when we couldn't use calculators to solve these, so we wanted to make it a little bit easier to read. What are we going to do? We're going to multiply by the square root of 8 on top and bottom. That way we can make this the square root of 8 squared. What are we left with? We have 8 square root of 8 over the square root of 8 squared will just be 8. Or the answer for this is root 8. All right, now let's talk multiplying any radical expressions together. If you have the nth root of a and the nth root of b, those are both real numbers, multiplying them together, it's just going to be like multiplying square roots together. We can combine the two. So this would be the nth root of a times b. But we have to be very careful. We can only do this if the expressions have the same index, or if they have the same nth value of the root. Now let's have you all go ahead and try these. Starting with this one, do they have the same index? We have 3 and we have 3, so we can just multiply these straight together. This would become the cubed root of 10. Okay, go ahead and try problem 2. What is the product of this? Well, what are our indexes? We have 4 and we have 3. 4 and 3 are not the same, so we can't reduce this. Okay, what about problem 3? For problem 3, we have 5 and 5 as our index, so we can multiply these together. This would become the fifth root of 2 times negative 6, or that would be negative 12. Remember, we do have to keep our negative sign here. And last but not least, what about root 3 times root 3? This would become square root of 9. Square root of 9. And what's the square root of 9? It's just going to be 3. So our answer for this is going to be 3. Now let's talk about how we reduce or we simplify roots. Starting off, how did we simplify square roots? For square roots, we looked for perfect squares or sets of 2. So if we're looking for squares, we're looking for 2 numbers multiplied together. How did we do that? Well, we put all of our values up at the top and we started dividing things out. Starting off, we have 1080. 1080 is divisible by 2, which will get us to 540. We can divide that by 2 to get us to 270. And we divide that by 2 to get us to 135. From there, let's try dividing by 5. That gets us to 27. 27 is divisible by 3, so that'll get us to 9. 3 will get us to 3, and 3 will get us to 1. So now what we do, we pull out perfect squares because we're dealing with a square root. We have 2 2's we can pull out, and we have 2 3's. Now let's also list out all of our variables. How many do we have? We have 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6, 7 y's. Again, any groups of 2 we can pull out. So what do we pull out? We pull out a 2 and a 3. So this will become 2 times 3. We pulled out 2 sets of x's, so that would be times x squared. Times we pulled out 3 sets of y's, y cubed. And whatever is remaining, we keep on the inside. So that would be 2 times 5 times 3 times x times y. Or, fully reduced, this would be 6x squared y cubed root 30xy. Okay, what about for simplifying the nth root? For example, if we're looking at a cube root, we're going to look for perfect cubes. What does that mean? It means we're looking for groupings of 3, a number multiplied 3 times by itself, to answer this. Let's go ahead and see what that looks like. We have 128. To start, we're going to divide 128 by 2. What is that going to get us? That's going to bring us down to 64. 64 we can divide by 2 to get us to 32. Divide that by 2 to get to 16. Divide that by 2 to get to 8. 2 to get to 4. 2 to get to 2. And 2 to get to 1. Now because this is a cube, we're looking for groups of 3 now. So we have one group of 3 there, and we have one group of 3 there. That means we pull out a single 2 for each of these groups of 3. We're looking for group sizes of our index. Let's also write out all of our x's. So we have how many? 1, 2, 3, 4, 5, 6, 7. Again, we're going to do groupings of 3. So because our index is 3, we're doing groupings of 3, meaning we can pull out 2 x's and we're left with a single x inside of the radical. When we write this out, we'll have 2 times 2, or 2 squared, times x squared. What's left inside the cubed root is going to be our leftover 2 and x. Or the answer for this is going to be 4x squared root 2x. So keep that in mind. When we're simplifying nth roots, you're looking for groupings of size n. For cube roots, it's 3. For fourth roots, it's 4, and so on. Now let's have you all go ahead and try some of these. How are we going to simplify the cubed root of 54x to the 5th? What's that going to be simplified? This one's simplified. What size groupings are we looking for? Well, we're looking for groupings of our index, or 3. Let's go ahead and write out what all of our factors are. For 54, what do we have? Well, 54 will be divisible by 2 to get us to 27. 27 is divisible by 3 to get us to 9. 3 will get us to 3, and 3 will get us to 1. So we're looking for groupings of 3. We have 1 3 that we can pull out. What about our x's? How many of those do we have? We have 1, 2, 3, 4, 5. Meaning we have one grouping of 3 that we can pull out, and we have 2 x's remaining on the inside. So our solution for this is going to be 3x, and we'll have the cubed root of 2x squared. Okay, what about problem 2? How are we going to simplify this? For this one, we're looking for groupings of 4. So let's start out with 96, and let's reduce that. 96 is divisible by 2, which will get us to 48. 48 is also divisible by 2. That'll get us to 24, which is divisible by 2, gets us to 12. 2 gets us to 6. 2 gets us to 3, and 3 gets us to 1. Now our index is 4, so we're looking for groupings of size 4 now. We have 4 2's there, so we can pull that out. We're left with a 2 and a 3 on the inside. Now instead of writing out x to the 8 and y to the 30, are these divisible by 4? Well, x to the 8th is x squared to the 4th. So if we have the 4th root of x squared to the 4th, the 4 and the 4th will cancel out. What about y to the 30? Y to the 30 isn't divisible by 4, but what we can do is we can split it up into a number that is, like y to the 28th, and y squared, whatever is not divisible, what's left over, is what's left inside. So y to the 28th, that would be y to the, let's see, that would be y to the 7th raised to the 4th times y squared. So what does that mean? Well, we have a 4 and we're looking at a 4th root, so those are groupings of 4. Meaning that, what do we pull out? We can pull out a 2. We have x squared to the 4th, 4 and 4, those cancel, so we're left with x squared on the outside. We had 7 groupings of 4, so we have y to the 7th on the outside. What's left on the inside is a 2 and a 3, so this is the 4th root of 2 times 3, or 6 times y squared. So those are our solutions. Now we're going to do a couple that are a little bit more difficult. We're going to have to multiply these together and then simplify. Let's walk through this first one and then we'll do the second one. Leave the second one up to you. So for this one, first thing we have to do is multiply these together. So we'll get the 4th root of 81 times 32, or that'll give us 2592. How many x's do we have? Well, we have x to the 5 cubed, or x to the 8, and we have y to the 5th. Let's start by pulling out the x's and y's, so this should be pretty easy. X to the 8th is the same thing as x squared to the 4th, so we'll pull out an x to the 4th. And y to the 5th is not divisible by 4, but that's the same thing as y to the 4th times y to the 1. So what are we pulling out? We're pulling out an x squared, and we're pulling out a y to the 4th. Okay. Now let's divide 2592 and see what we can pull out. 2592. Let's see, if we divide 2592 by 2, that'll get us to 1296. If we divide that by 2, that'll get us to 640. Divide that by 2 will get us to 320. Divide that by 2 will get us to 180. 2 again will get us to 90. 2 will get us to 45. Okay, so we're down to 45 here. Let's keep doing that over here. 45 is going to be divisible by 3. And when we pull out a 3 from 45, we're left with 15. Pull out another 3, we're left with 5, and 5 gets us to 1. Okay, so now we're looking for groupings of 4. We have one grouping of 4 2's, and the rest has to stay on the inside. Meaning that we pulled out a 2, we pulled out an x squared, we pulled out a y to the 4th. What's left inside? 2 times 2 times 3 times 3 times 5. Throw that all into your calculator, times 3 times 3 times 5. That'll get you 180. So this is the 4th root of 180, and we were left with 1 y on the inside. All right, now go ahead and try problem 2. What is this going to be fully simplified? For starters, let's multiply everything together. We have negative 1 times negative 2. So on the outside, we have a negative 2. and we have the cubed root of 2 times 15, or 30. We will have x squared times x to the 5th. That'll get us to x to the 7th, and y cubed. Let's start by factoring 30, see what we can pull out. If we pull out a 2, we get to 15. Pull out a 3 from that, we get to 5, and 5 gets us to 1. So we don't pull out any constants. But x to the 7th, let's change that to something that's divisible by 3, or x to the 6th times x, and we have y cubed. Now the cubed root of x to the 6th, that'll be the same thing as x cubed squared. So we're going to pull out an x squared. We're left with a single x inside, and we pull out a y. Meaning that when we do this, we have negative 2 x squared y times the cubed root of 30x. Right. Now that's it for multiplying and simplifying. What about combining radical expressions, but this time we're talking about dividing? So if we have two numbers here, if we have two numbers that are both to the nth root, so we have the nth root of a and the nth root of b, then the nth root of a divided by the nth root of b, just like with square roots, we can put it all under the root. So that becomes the nth root of a divided by b. What does that mean? For something like the square root of 18x to the 5th divided by 18x to the 3, that's the same thing as putting it all under the square root. So we get 18x to the 5th over 2x cubed. And then what we can do is we can simplify. 18 divided by 2 is going to be 9. Next to the 5th over x cubed, we subtract these. So this would be x to the 5 minus 3, or x squared. What is our solution going to be? Square root of 9 is 3, and the square root of x squared is going to be x. If we want to be really precise here, we need to make sure that x always remains positive, so we throw in an absolute value of x there. Okay. What about for this next one here? We have the cubed root of 162x to the 5th divided by the cubed root of 3x squared. These both have the same index, so we can throw these all under one large cubed root, where we'll have 162x to the 5th divided by 3x squared. And then we can just simplify. What's 162 divided by 3? Well, that's going to be 54. So we'll have the cubed root of 54 times x to the 5th over x squared will be x cubed. So we know we're going to pull out an x from that because we have cubed root of x cubed. And now we have to figure out what the cubed root of 54 is. So let's go ahead and find our factors. Factors of 54 are going to be, we pull out a 2, that gets us to 27. Pull out a 3, that'll get us to 9. 3 will get us to 3, and 3 will get us to 1. We have a grouping of 3 here, because we're dealing with cubed roots, and we have a 2 left inside. So this simplified would be 2x to the cubed root, or times cubed root of 2. Right. Now you go ahead and give this one a try. What's the cubed root of 250x to the 7th y cubed over the cubed root of 2x squared y? What's our first step? Put everything under one large cubed root. So we have 250 x to the 7th y cubed over 2x squared y. And now we're just going to start dividing and simplifying. 250 divided by 2, that'll give us the cubed root of 125. We have x to the 7 on the top, x squared on the bottom. That'll leave us with 5 x's, and we'll have 2 y's. Right, so let's factor 125, see what we can pull out. If we divide that by 5, we get to 25. Divide that by 5, we get to 5. And divide 5 by 5, we get to 1. So we have a grouping of 3, which is what we need because our index is 3. And we're pulling out a 5. So we have 5 cubed root of x to the 5th y squared. Now if we write those out, we have 1, 2, 3, 4, 5 x's, and we have 1, 2 y's. So we have a group of 3 x's we can pull out, but we're left with x squared and y squared inside, meaning that this simplified will be 5x times the cubed root of x squared y squared. All right, so there's that. We just have one more thing to talk about here, which is rationalizing the denominator. So let's think about this. How did we simplify 3 over the square root of 2? What did we do? We multiplied by the square root of 2 over the square root of 2. Why is that? Because it got us a perfect square underneath our square root in the denominator. Right? We're left with 3 square root of 2, and on the bottom we have the square root of 2 times the square root of 2, or the square root of 2 squared. So we have square root of 2 squared. Those two 2's would cancel out, and we'd be left with 3 root 2 over 2. So what this means for larger values, for larger roots, is we want to have perfect ends. Right? In this example, we're looking at the cubed root, so we want perfect cubes. Or anything in there, we need to have cubed. How does that work? Well, let's rewrite this. So this is the cubed root of 2x divided by the cubed root of 6 is going to be 2 times 3. We have x squared and we have y cubed. Now we want the powers of everything in the denominator to equal 3. So we have 1 power of 2. We're going to need 2 more of those to make this 3 powers of 2. Right? X squared times, or 2 squared times 2 gives us 2 cubed. That would allow us to cancel this out. We have 1 power of 3, so we'd need 2 more to get that to 3. Right? 3 times 3 squared would get us 3 cubed. We have 2 powers of x, so we're going to need 1 more to get to x cubed, and we need no powers of y. Y is already at 3 cubed, or cubed. And what we multiply on the top, we also multiply on the bottom. Or what we multiply on the bottom, we multiply to the top. So we're going to be multiplying 2 cubed, or 2 squared, 3 squared, and x to both the top and bottom. From here, we're just going to simplify. So 2x times 2 squared, 3 squared x will give us the cubed root of 2 cubed times 3 squared times x squared on the top. And then the bottom, if everything came out properly, being as we're dealing with a third root, an index of 3, we want everything to have powers of 3. So we have 2 times 2 squared, that gets us 2 cubed, so that works. We have 3 times 3 squared, that gets us 3 powers of 3, so that works. We have x squared times x, so that'll get us 3 powers of x, and we have 3 powers of y. And look at that, everything cancels out. We have cubes and we have cubed roots, so all of those will cancel. We're left with 2 times 3 times x times y in the bottom. And can we pull anything out from the top? We have the cubed root of 2 cubed, so we have a 3 and a 3. That means we can pull out a 2, but the rest, the 3 squared and the x squared, has to remain in. And our last step here is to just simplify. We have a 2 on the top and the bottom, so we can cancel those out. And our solution here will be the cubed root of 9x squared over 3xy. All right, now we have, it's your turn. We have the cubed root of 5x squared over 12y squared z. Let's go ahead and simplify that. We can reverse this to the cubed root of 5x squared over the cubed root of 12y squared z. And now try to rationalize this denominator. What's our value going to be? Well, we need to split up the denominator. The denominator is 12. 12 is the same thing as 3 times 2 squared. We have y squared and we have z. We still have everything the same on the top, so we have the cubed root of 5x squared. Now our index is 3, so we want to get all of our powers on the bottom to be equal to 3. We have 1 3, so we're going to need 2 more of those. We have 2 2's, so we're going to need 1 more of those. We have 2 y's, so we're going to need 1 of those. And we're going to need 2 z's. Right, we're trying to get all of these values of these exponents to be 3. What we did to the bottom, we also have to do to the top, though. So we're going to multiply by 3 squared times 2 times y times z squared. And what does that give us? Well, on the top, we're going to have the cubed root of 5 times 3 squared, or 9, times 2, times x squared times y times z squared. And in the bottom, what are we going to have? Well, we should have everything to the third power because we're dealing with a cubed root. So we have 3 times 3 squared, that'll give us 3 cubed. We have 2 squared, so that'll give us 2 cubed. We have y squared times y, so that'll give us y cubed. And we have z times z squared, so that gives us z cubed. That leaves us on the bottom with 3 times 2 times y times z, or 6yz. And what's left in the top? Well, we have 5 times 9 times 2. That's going to give us the cubed root of 90, and we have 2 x's, 1 y, and 2 z's. So our answer is the cubed root of 90x squared yz squared over 6yz. And that's what we have for multiplying and dividing radicals. Go ahead and get started with your work.